When it comes to the electricity, there are going to be a lot of equations that simply have to be memorized. A lot of those equations are going to be using terms that you may not be familiar with. So it's a good idea to make sure you have a firm grasp on the common terms used to describe electricity before you start to memorize the equations. When discussing electricity, we frequently refer to charge. And charge is simply a physical property of particles to either attract or repel one another. We describe charge as either being positive or negative. All you really have to know about charge is that like charges repel each other and opposite charges attract each other. When you draw the field lines for a charge, you draw them in the direction that a positively charged proton would travel. So if you had a positively charged proton next to another positive charge, they would repel each other, pushing the proton away. On the other hand, a proton next to a negative charge would be attracted to the negative charge and move towards it. Most parts of electricity are completely analogous to water. So if we're comparing electricity to water, you could envision a coulomb as one drop of water, or a small, tiny piece of charge. You've probably heard the term volt or voltage a lot, especially when talking about batteries. Voltage is simply a difference in charge. So in a battery, one end will have a lot of positive charge. The other end will have a lot of negative charge. The greater the difference between the amount of positive charge and the amount of negative charge, the greater your voltage. To understand why a difference in charge creates a higher pressure, think about a dam. When water is released out of a large dam, the water comes out with an enormous amount of pressure. In another video, we calculated the pressure from water to be the density of the fluid times the force of gravity times the height of the dam. The density of water and the gravity on Earth, those are pretty much constant. If we want to increase the pressure, our only option then is to increase the height. The greater the height, the greater the pressure. Or the greater the difference between the high part of the dam and the low part of the dam, the more pressure we're going to have. Likewise, if you have a lot of positive charge on one side of a battery and not a lot of positive charge on the other, that's going to create pressure or voltage. A joule is a measurement of work, and work is a change in energy. And when you do work, you're either putting energy in or taking energy out of the system. So whenever we talk about potential energy or kinetic energy, we're measuring that energy in joules. One definition of work is your force applied times the distance over which you apply that force. So if this child were to apply 1 Newton of force and push this wheelbarrow for 1 meter, that would be equivalent to 1 joule. In other words, one definition of a joule is a Newton meter. The standard definition of power is work divided by time. In electricity, we measure work in joules. So power would be a measurement of joules over time. In electricity, we're usually measuring time in 1 second. So a watt is equal to 1 joule per second. So if you go to the store and buy a 75-watt light bulb, that means that light bulb emits 75 joules of energy every second. When we use the word current to describe electricity, we mean it in the exact same way we use current to describe water or a river. In a river, the current describes the total amount of water that flows by a given point each second, or how much water do we have and how fast is it moving. We measure current in amperes or amps. 1 amp is equal to 1 coulomb, or 1 piece of charge traveling by each second. So if this were a dripping faucet, so if we used amps to describe a dripping faucet, each drop would be, we can see there are 3 drops of water falling each second. So the amps, or the measurement of our current, would simply be 3 drops of water falling down each second. So let's continue our water analogy to describe all the different components of electricity. If the water coming out of the hose is our electric current, then the pressure behind the hose, that's going to be our voltage. Each tiny drop of water that comes out of the hose, that's going to be a coulomb. The amount of force that's applied to her face by the water, and how far she gets pushed back, that's going to measure our work, which we describe in joules. If we look at the force applied to her face times the distance she gets moved back every second, that's going to be a watt. And if we look at the total amount of water that comes out of the hose each second, that's going to be our current that we measure in amps.